Morning students. Today we are going to see the topic called electrochemical machining process. Introduction. Electrochemical machining ECM is one of the recent and most useful machining process. In this process, electrolysis method is used to remove the metal from the workpiece. It is best suited for the metals and alloys, which are difficult to be machined by mechanical machining process. Principles of electrochemical machining process. This process is based on the principle of Faraday's law or electrolysis, which may be stated as follows. The first law states that the amount of material dissolved or deposited is proportional to the quantity of electricity passed. Faraday's second law. The second law proposes that the amount of change produced in the material is proportional to the electrochemical equivalent of material. Basically, in electroplating, the metal is deposited on the workpiece, while in ECM, the objective is to remove the metal from the workpiece. So the reverse of electroplating is applied in ECM process. Therefore, the workpiece is connected to the positive terminal called anode and tool connected to negative terminal called cathode. When the current is passed, the workpiece loss metal and the dissolved metal is carried out by circulating an electrolyte between the work and tool. Construction of ECM process. The schematic arrangement of ECM process is shown in figure. It consists of a workpiece, tool, servo motor for controlled tool feed, DC power supply, electrolyte, pump, motor for pump, filter for incoming electrolyte, and reservoir for electrolyte. A shaped tool electrode is used in this process. Which is connected to negative terminal cathode, and the workpiece is connected to positive terminal anode. The tool used in this process should be made up of material which have enough thermal and electrical conductivity, high chemical resistance to electrolyte, and adequate stiffness and machinability. The widely used tool material are stainless steel, titanium, brass, and copper. The tool is of hollow tabular type as shown in figure, and an electrolyte is circulated between work and the tool. Most widely used electrolyte in this process is sodium nitrate solution. Sodium nitrate solution in water is a good alternative, but it is more corrosive than the former. Some other chemicals used in this process are sodium hydroxide, sodium sulfate, sodium fluoride, potassium nitrate, and potassium chloride. Servo motor is used for controlling the tool feed, and the filter is used to remove the dust particles from the electrolytic fluid. Working. The tool and workpiece are held close to each other with a very small gap of 0.05 to 0.5 mm between them by using servo motor. The electrolyte from the reservoir is pumped at a high pressure and flows through the gap between the workpiece and the tool at a velocity of 30 to 60 meters per second. A mild DC voltage about 5 to 30 volts is applied between the tool and workpiece. Due to the applied voltage, the current flows through the electrolyte with positively charged ions and negatively charged ions. The positive ions move towards the cathode, while negative ions moves towards the workpiece anode. The electrochemical reactions take place due to this flow of ions, and it causes the removal of metal from the workpiece in the form of sludge. These are the step-by-step process of the electrochemical machining process carried out. Power supply. The electrical power supply circuit is in ECM is simple when compared to EDM. In ECM process, the applied current is of the order of 50 to 40,000 milliamps, and the voltage on most machines is from 5 to 30 volts DC. The current density of this process is generally high, 20 to 300 amps per centimeter square. Cut-off circuits are also available in the power supply unit to stop the supply of the power to the machine gap. Next, we will see the analysis of the metal removal, how it happens. In electrochemical machining process, electrolysis method is used to remove the metal from the workpiece. A mild DC voltage of about 5 to 30 volts is applied between the tool and the workpiece. So the current in water flows through the electrolyte solution of NaCl with charged ions. Many chemical reactions occurs at the cathode and the anode. It is clear that the material removal rate increases with current, and the machine can be operated at high feed rate condition. The following factors which affects the current flow are gas evolution H2 at the cathode surface may reduce the current flow. Polarized ionic layer may build up at the electrode, causing large voltage drop near the surface. When electrolyte is heated more, it results in boiling. it automatically reduces the electrolytic action. The following reaction are possible at cathode tools. Na plus C minus equal to Na. Na plus H2O equal to NaOH plus H plus. 2H plus 2E minus equal to H2. Thus, there is no deposition on tools and only hydrogen gas is evolved. Similarly, following reactions occurs at anode. Fe gives Fe2 plus 2E minus. Fe plus 2Cl minus gives FeCl2. Fe plus 2OH minus gives the FeOH2. FeCl2 plus 2OH gives FeOH2 plus 2Cl minus. This shows that workpiece goes into a solution and machine. W equal to EIT by F, where by the combination the Faraday's first law and second law of electricity we get, where W is the mass of ion dissolved in kg. E is the equivalent weight of substance dissolved. T is the time in seconds. F is the Faraday's constant, which is nothing but 96,500 coulombs equal to 26.8 amperes per hour. In ECM, tool material, tool design and installation. Since the tool has no contact with the workpiece, there is no tool wear. So any material that is good conductor of electricity can be used as a tool material. The general requirement of a tool material in ECM process are, it must be a conductor of electricity. It must be chemically inert to the electrolyte. It must be easily miscible. It must be rigid enough to take up the load due to fluid pressure. Most commonly used tool materials are copper, brass, titanium, copper tungsten, and stainless steel. When the electrolyte is made of sodium or potassium, the other materials which can be used as a tool material are aluminum, graphite, bronze, platinum, and tungsten carbide. The following table shows the properties of some of the tools materials. Since the electroforming and cold forging are used for tool shaping, as the surface finish of the workpiece mainly depends upon the condition of the bottom face of the tool, that portion of a tool should be polished. The tool is made hollow for drilling holes so that electrolyte can pass along the bore in hole. The outer surface of tool is insulated by vinyl, Teflon, enamels, or high temperature varnishes. While designing the tool, the following two aspects are important. Determine the tool shape so that the desired shape of the job is obtained under existing machining conditions. Design the tool by consider the electrolyte flow, insulation strength, and fixing arrangements. Electrolytes. In ECM process, the electrolyte is used for the following purposes. It carries the current between tool and the workpiece. It cools the cutting zone, which becomes hot due to the flow of high current. It removes products of machining from the cutting zone. Electrolyte can be selected on the basis of material to be machined. The sodium and the potassium salts are most commonly used as electrolytes. Iron-based alloys, 20% of sodium chloride solution in water. Nickel-based alloys, mixture of a brine and H2SO4, sulfuric acid. Ti-based alloy, 10% HF plus 10% HCl plus 10% HNO3. COCr based alloy, NaCl. WC based alloy, tungsten carbide based alloy, strong alkaline solution. The essential characteristics of electrolytes are as follows. It should be good conductor of electricity. It should have non-corrosive property. It should be non-toxic and chemical stability. It should have low viscosity and high specific heat. Surface finish. The following factors govern the accuracy of the parts produced by electrochemical machining. First one is machining voltage. Second one is tool feed rate. Third one is temperature of electrolyte. Fourth one is concentration of electrolyte. Next section we will see about the advantages, disadvantages and applications of ECM and various types of ECM. Thank you.